Hi there. So I had a request to do problems 18 and 19 from homework 2, and I'm going to do it a little different because I'm also going to try to do the Excel part. So if you're interested in how this fits into Excel, you can see the end of this as well. So this is problem 18 from homework 2, which is a kind of a combo that goes with 19. We have a woodlot that's going to produce $1,500 of revenue every 5 years. At 9.5% interest, the revenue stream from 10 cuttings has a present value of how much? So, right to it. Timeline 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be there. So, and that would be at 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 0. Right, and we know I'm not going to draw them all out, but we have all of these. Sorry, little plus 1,500. So we're going to get 1,500, right? A, that's what A is, all the way out to here. So if we look at our sheet, I think we're all getting pretty good at this. It's a series. It's not every year. In this case, it's every 5 years. It does end because we're only going to do 10 of these. We don't want the present, we want, or the future, we want the present value. So we're into this little ugly one that we use in our campground stuff. It's the big one. So let's do that here. VO equals A, and remember, I'm going to do this in the spreadsheet afterwards. So if you're interested in how this works in a spreadsheet, I will do it there, and maybe that'll be helpful as well. Right, so 1 plus I to the n. I'm just copying it off my sheet. 1 plus I to the t. Okay, and now I want to know what I know. I know A in this case is 1,500. I know that n, which is right the number of years between payments, is 5. T, and this might be the one that threw people off. It's not the 10 payments, it's the 50 years, the length of the time horizon from here to here. So 50 years, and I, in this case, we've been told is 9.5. See up there from where we got it. So, and we're just plugging those values in, 1,500, 1.095 to the 50, that's the t, minus 1 over 1.095 to the 5 minus 1, that's our n, times 1.095 to the 50. That's what things look like. If you want, of course, you can add some more brackets, make sure that that 1.095 to the 50 gets captured there. If we solve that, we are going to end up with 2,584. And I can show you where we do that now because I'm doing this. I can share this sheet over here. And where is it? There it is. Okay, so now you should be looking at the Excel spreadsheet, and I'm going to put that equation in here. So first thing I'm going to do, I like to expand this bar so you have this little arrow. You can make your formula bar bigger or smaller. I've copied the equation thing over here just so we can see it. Remember, we're doing this one at the bottom. So you always start an equation out with equals because, of course, we want to know what it equals. And now we're going to plug our values in. A is 1,500 times. We need to have the times in there before we hit the brackets. And it's 1.095 to the 50. Remember, that was our t minus 1. Close that up. We're going to have our division thing there. Now we want to get our open brackets for the bottom and our open brackets again for this 1.095 to the n. So to the, you notice the to the, it's the caret there above the 6, to the 5, minus 1 times, you got to have your times in there, 1.095 to the 50, which is t. Close those brackets, close them again. So you'll notice they're color coded. So red to red, black to black, that's what I get. So when I do enter, I get my 2584. So that's kind of how that would go in Excel. So for the second part of this, I can go back to my document camera, and now you should be looking at this sheet of paper again. I've got this thing over here where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. That's 50 years out. And now we're going to go out to 100. So we want to know 10 additional cuttings. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those ones got kind of stretched out, but right, we've got all of these A's all the way out to there in 5-year increments. And we want to get it back to here. So it's the same formula that we had up here. I'm not going to write it down again, but I will write down what we know. Again, this is 1500 and the N is 5. That's the in-between periods. The T, instead of 50, we're going to look out T equals 100. And let me do that so you can see it. And the I equals 9.5. So if I'm going to plug that in here, right, VO is going to equal 1500, 1.095 to the 100 minus 1, all of that over 1.095 to the 5 minus 1 times 1.095 to the 100. Okay, if I do that, I should get 2612. Let's check it out. I'll go back into the spreadsheet. We'll do this 2 different ways, just so that you can see how it could be done differently. So let me share my spreadsheet again. Now you guys should be looking at the spreadsheet. Easy way to do this would be to copy this equation, everything that we have. I can paste it down here. So if you remember, like we did before, we used the exact same equation. And what changed was that we went from 50 years to 100 years. And that would just change the T in the equation. The interest rate's the same, the N here of 5 is the same, and the $1,500 is the same. So when I click enter, magically I get my 2612. Okay, so let's try it one other way, because another way that you could notice this, if we go back to our document camera and we start up here at the top, is that we've already figured out what this is, right? That the 50 years present value is 2584. So what if we said for 50 years, we know that the VO equals 2584, and we're going to have another 50 years, right? With all these things in it, basically this timeline exists here. And we know that the VO for that second 50 years is 2584, right? Because we already figured out what that was, but it's sitting here. So it should be that a VO for this second one, right, is going to equal the original numbers, which are the first 50 years, which we've already solved to year 0 at 2584, plus this one, which we've already crunched. We know what all of these would be out to 100, right, 2584, but it's sitting out here at 50 years. We can discount it, 1.095 to the 50. So we're basically saying it's a single value that's sitting out there in the future, a VT 50 years from now, and we want to discount it, slide it over on our timeline 50 years. And what should this equal? Thinking it's going to be 2612. So let's jump again over into our spreadsheet and see if that is the case. So if here instead, I was to say, no, I'm going to take equals this cell, which is my 2584, plus this cell by 2584 divided by, open my brackets, 1.095 to the 50. Close those things, magically I get the same answer. So doesn't matter how you go through these things, as long as you're consistent, you capture everything. There's many ways to solve them, right? We could have broke it into little 25-year blocks and done 4 of them, or we could have done every single one individually. So I hope it helped to see this in Excel. That was kind of the point of the first homework. You can still turn those in and get credit. If you're late, of course, you can only get 4. But if you turn it in on time and you're going to correct it, you get a 5. But it's more important that you learn kind of the concepts of time and getting these values into the Excel sheet, right? There it is. There it is. That was an example of me just copying it. If you want, when you're doing Excel, sometimes I paste these things in here so everything, I'm looking at it as I do it. But anyway, I'll stop sharing and I'll see you guys around.